Okie dokie, let's go over Linux fundamentals, room number 3. So is this the hardest one? Pretty easy? Don't know yet. We have one that still has to do it, but scale of like 1 to 10. Who thinks it was like a 7 or higher?
69.
Okay. 7 or 10 being the hardest.
I say 7's pretty solid.
7 mostly? Okay.
Solid 120.
But doable, right? You guys, most of you have finished it and you understood it. Somewhat, right? Hopefully after I lecture on it, you'll be 100% on this. Okay. So what were some of the things that we learned or that you guys had like as a takeaway? Like what were some of the commands that you learned or things that you learned? What was new in this lesson? Wget. So what does that mean? What is Wget? Downloads a file, right? Okay. So now in order for Wget to work, that's you're pulling information. What does the other server have to do? What was the step before you used the Wget? Do you remember? You had to set up a web server, right? And you had to host that file. So what did we do to host that file? What's that? No, that'll change the directory. So if we need to get into that file or that folder, we can. But what was the actual web server that we had to use? Python 3, yes. So the web server was, we used Python for that. And Python is a coding language, and we will get into Python in much more depth. You use Python a lot when you're doing pen testing and any type of scripting. So what you did on your remote box was you said, hey, here is this text file. And then on your attack box, you said, hey, give me that file. And that was the GET request. And it sent back to you that actual file, right? So if you did not do that web server, if you didn't set that up, then you would have no way to get that file. And some of you probably just typed in the command and didn't understand and then reread it and realized, hey, I had to set up a web server. So what you just did when you did the Python 3 web server here, if you would have had a file called index.html in there, you could have gone from a web browser and hit that directory, and it would have been a fully functioning website because that is a full HTTP server. It's a super lightweight one. It's not made for production. It's made for testing things. But you could have navigated to that from an actual web browser and seen like all the graphics and stuff. So you'd set up just a normal web server in that directory. Also, with the GET request, that's the same thing as you typing it into a web browser. When you type that in and hit enter, it's sending out that same GET request. This is just doing it via the terminal. And why do you think in cybersecurity we would use this, little web server and this GET? Why do you think we would use that? What's the use case? What?
Avoid being on the internet.
Avoid being on the internet? Maybe you don't have access to, the outside network, but you still need to get files, right? So when we're doing, cybersecurity, if we're hacking into a machine, are we going to be standing in front of that machine, or are we doing that remotely usually? Remotely. So it's not like we can plug a flash drive in and say, give me all of the, give me all the goods. Give me those text files, that, username and password list, right? So we have to figure out a way to pull that information off. So when you pull information off of a machine, it's called exfiltration. Okay, you need to get the information out of there. And again, this is going to be more of the cyber stuff. This is less of the IT fundamentals, but I want you guys to be aware of the why behind this. Why are we learning this in the IT class? Well, it's because later on in cyber, we're going to be doing this stuff a lot. Whenever you get into CTFs, whenever you get into any of the rooms where you actually have to hack into the machine, you're going to be setting up this little web server to move files back and forth, because that's the easiest way. What else did we learn? What about like scheduling tasks? Did we learn about that? Yeah.
Cron tab-E is from edit all, and cron tab-L to list it.
Cron tab, and there was a -E, and that was to edit, right?
Yep.
And then there was a -L, and that lists. So what is cron or cron tab? In this case, you guys learned cron tab as the tool, but what is a cron job? Anybody know?
Come on, Lewis, you should know.
There's like a whole section on it.
I don't know.
Okay, well, I have a video that we're going to watch after this screen recording that goes in depth about cron tabs or cron jobs as a whole, because on Linux, if you're going to be a Linux sysadmin, you're going to be using them all the time. And all cron jobs are a list of instructions that are set to run at certain intervals. So you could say every day I want you to clear temp files, or every night at 5 minutes after midnight I want you to back up this user's files, things like that. So cron is a way for you to automate those tasks. Okay. So as we go through, if there's any other notes, we'll be sure to jot those down. But let's get into this room. I have not done this room yet, so this is going to be fresh for me. Okay, so the first thing we see here are the text editors. And I am so glad they started with Nano because that is my favorite text editor. Once you get into IT and around people that use it, you'll find that it's like Ford versus Chevy. Some people love Vim, others like Nano, others like Emacs is another one that you'll run into. I think Vim is super confusing with the different keystrokes that you have to know, but it does have a lot of features, so people have gotten used to them. And actually, if you go into Google Classroom, you'll see a thing called Vim Adventures. It's a little game that you can play to learn all the hotkeys for Vim. But these are just text editors, okay? So Nano is the first one, and like all of our other tools that we've learned or commands that we've learned, the syntax is the command that we want it to run, so in this case Nano, and then the file afterwards. Okay, so if I wanted to create a text document called llama.txt, I would type Nano and then llama.txt. Okay, that would create a new file. Now, if that file already exists there, then it's going to open up that file. You're saying, I want you to open up the file llama.txt. Okay? I'm going to tell you something right now that will save you a ton of headaches in the future. If you don't like case sensitivity with Linux, that's the biggest thing. If you don't type that exactly correct, you're just going to create a new file. Let's say you're trying to open up a text file that's there, and you're going to open it up, you're like, oh, this log file is blank. There was no information in here. Well, that's because you typed it wrong. You did like a capital L, or you put something in there. So you have to make sure that your caps are 100% correct. Always do an ls first is my first tip. What does ls do? It's going to list all the files that are there, right? And then the other thing that you do is put in the first letter and then hit what key? Tab. Tab's going to auto-complete that command for you. That is making sure that you 100% have it spelled correctly because the computer is telling you what to put in. Does that make sense? Are you guys using the autocomplete, the tab key? That's going to save you a ton of time. And it's going to become muscle memory. Just like if you hit up, it's going to bring your last command up. And if you hit up like 3 more times, it'll bring up your last 3 commands. So that's little quick things around the terminal that'll just make your life that much easier. Okay? So it's easy to get started with Nano. To create a file, blah, blah, blah. We just talked about that. We'll scrolly McScrollers in here. Create a new file using Nano. So what do we want to type in to create our new file? What do I have to type here? What's the first thing I type in? You all did this part. Nano, right. And then what do I want to put after that? What's that? Turtle? Turtle.txt, enter. And now I'm in there. So now I can write turtle. Did I spell turtle right? It looks weird. I think I did. So now here, if you notice on the bottom of Nano, there's a couple things. You have all of your different options. You know how when you're using Microsoft Word, you're used to seeing like the file, edit, all that at the top? It's the same thing down here. These are just your different commands that you would put in. So if I wanted to save this file, it would be the write out, because it's going to write it out to that actual file itself. Or if I just want to exit, it's Control X. Okay? So if I hit Control X to exit out of here, it's going to say, would you like to save what you have right now? I'm going to say yes. Hit enter. So now when I cat turtle, note I stopped at T. I'm hitting tab, T-U-R, there you go, and hitting enter. Now I can see my text in there is turtle. So that begs the question, what's the difference between cat and Nano? They're both showing words on the screen, right? What's the difference? Yeah?
You can like actually modify and edit stuff with Nano.
Yes. So Nano is an editor where Cat's just going to display it up on the screen for us, okay? So we're going to look at this next task here. Edit task 3 located in the TryHackMe home directory using Nano. What is the flag? Okay, so we'll complete that one. We're good there. So task 3. Where is task 3? ls. Oh, I made the mistake a lot of you did. What machine am I on right now? I am still on attack box, right? So what do I need to do in order to get to my remote machine? What do I have to type here? TryHackMe at 10.10.88.242. Are you sure? Absolutely. And the password is TryHackMe.
Yeah, I typed in Y thinking it would be that.
All right, so let's see if this is in here. We have task 3 here, right? So we'll type nano task 3, letting it autocomplete, and there is what we need to put in for our answer. Question done. Oops. Yep, it will absolutely do it for you. So THM, and then woo woo. Okay, now we're moving on. Yes, this is the fun one. Okay, so this is the Wget that we were talking about. Okay, so I'm going to come over to this is my remote machine now, and you'll notice that I have 2 different things open. Okay, so this is going to be very common, where you'll fire up a web server or a reverse proxy in one terminal, and then you'll have your other one that you're doing work. Okay, so the file that we're trying to get is transferring files. Okay, so we need to first set up our web server in the actual directory where we want to get the file. Okay, ensure you are connected and deployed to that instance. That we are. Boom. Now use Python 3's HTTP server module to start a web server in the home directory of the TryHackMe user. So what's the command? I'm not really sure if I'm in the right directory. What's the command that I put in order to find out what directory I'm in? pwd. We want to print the working directory, right? pwd. Enter. Okay, we are in TryHackMe. We are ready to roll. So what is the Python command that we need to put in here? Or where can I find that? So it's right there, and it's also under the hint. So in this case, we're going to do Python -m, and we want to set up the HTTP server. Boom. Okay, so now it is serving up on HTTP. So I'm using Hypertext Transfer Protocol, and on that port 8000, it is now putting that file there. Okay, so now if I come over to my local machine, so my attack box, I can do my git, or my wget, right? Wget, in order to get that file, HTTP 10.10.88.242/.flag.txt. Let's see what happens. Awaiting response. We got a 404. So what did I mess up? 10.10. Yes. What is super important? Does anybody know what does HTTP, what port does it run on? Anybody have any ideas? Runs on port 80. So if you do no port on there, it's going to natively try to go to port 80. Well, is that where this is being hosted right now? No. What port is it being hosted on? On 8000. Yep. And if you look, I now have that file. You can see it downloaded 100%. And then I see right here that a GET request came in for that file. So we now have it on our local machine. And then what are the contents? So what do we want to do to show those contents? What do I type in? ls, that'll see. Okay, yep, we can see that the file ls-lah. We can see that the file, double check it got moved over. I actually forgot what the name of the actual file is. .flag. Okay, there it is, .flag.txt. Yep, it's over here. But now how can I read that file? Cat dot flag dot text. Yep, absolutely. There we go. So there is our flag, THM, Wget underscore web server. Submit, completed, blah, 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 blah. See how you can read the documentation. Yes, and then in order to stop something, notice that I don't have my normal terminal where I could type in, right? This is where we type stuff in. You see how it's just sitting here? Because it's a web server. It's taking requests, so that's why it's just going to keep ticking down every time we request a file. In order to stop that, we have to hit Control-C. And that's common across Linux to stop things. Or let's say you mess up a command, you can do Control-C in order to get out of it. So we completed that. All right. We are now on to processes. Now, this is a little more advanced, I guess. We're only 3 weeks in, so we haven't got to like what processes are. But on no matter what computer, it's really the smallest part of an application. Okay, the process is what runs the entire application. So if you open up the process manager on your Chromebook right now, do they block that on you guys, or can you do it? You can't get to Cron.
No, we can't.
Yeah, we can't get to Cron.
You can or you can't?
Can get to Cron.
Okay, then you should be able to see what processes you have running on your Chromebooks. The actual yeah, so what do you have available there? So let's see what commands are there. Do a question mark? Or type help, actually.
Yeah, it's just help. Help.
And so basically you can ping.
We can run our stuff.
So if you type in top, you'll see your top processes that are currently running. Okay, so those are all the some of the processes that are currently running. And with the different tabs, those are different processes on Chrome. Okay, so it's the smallest application that you'll see, and this shows everything that's running. So if you want to kill it, you're able to. Okay, so let's write down some of these commands. Okay, so we had top, and what does top do? What does the top command do? In the room for TryHackMe. It shows you the top level the processes that are going on. So let's bring it over here. How would we find out more information about top? Exactly. So I typed in man top, and it's going to display your Linux processes. Okay. Then you could go through and see if there's other things you can type in, but we'll just type it in and see what it looks like. So these are all the different things that are currently running. Who is the current user? What? So here we have TryHackMe plus. We have the time, the CPU, the memory. If there's any zombie processes, all that information is on here for you to be able to see if there's something that's maybe causing an issue. Okay. So we'll clear the screen. The top. Okay, what about PS? Did you guys learn that one? Yes. So, yep, PS, AUX, that's also going to show a list of the different processes that are on there. Oops. So we'll come over here and we'll do man, PS. Report a snapshot of all the current processes. So if we run, oops, quit, PS AUX, we get a snapshot, right? So what's the difference between top and PS? What's the difference? There's a key word there. It's the word snapshot.
Yeah, is top like real time or whatever? Like
It is. So if I'm on this one, I'll put top on this one here. And then here, you can see it stopped. And see how the information is changing, and on this one, the information is not changing. Okay, so this is kind of a live. This is just for now what's going on. Okay. So I'll write that down. PS is a snapshot or a point in time. Okay. So if we want to kill a process, what do we type in? You type in kill, and then you have to use the PID, or the process identifier. So if we look at back at our little terminal that's running top here, you can see the PID is listed right here. So if we wanted to kill this application, we would type in kill, and then whatever the PID is. So another command that we need to know is kill, and that will, I guess, when there's no other, it stops the process. I was going to say it kills it, but you can't use the word in the definition. Stops the process. Cool. Boom, 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 boom. So we're not going to go in depth about the systemd or systemctl, backgrounding and foregrounding. Don't really need to know that. Okay. README, completed. If we were to launch a process where the previous ID was 300, what would the ID of this new process be? Who are our math people in here?
It's super difficult to get.
What is it?
301.
301, exactly. So it just moves up by 1. If we wanted to cleanly kill a process, what signal would we send it? What's the signal? We want to do, keyword there is cleanly. SIGTERM. You guys spelled that right? It is. We'll note that one as well. I never used that one, but hey.
Isn't there sig kill and sig term?
Yeah.
And then kill just pure leaves it, and then like term cleans it up or whatever.
All right. So locate the process that is running on the deployed instance, blah, 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 blah. What is the flag given? Locate the process that is running on the instance, and what is the flag? So we are on our deployed one, so that's this guy up here. THM, there it is. Okay, so this is a TryHackMe thing. So you know how we can't see what that actually says if we maximize? So we'll come down here. We will maximize it so that way we can see. And then we're going to rerun that command. So now we can see it is THM processes. I believe. Is that the right one? Woohoo! Okay, what command will we use to stop the service, my service?
Systemctl stop my service.
Yep. Oops, that's not going to like that. Okay, so it's worth noting or writing this down because you're going to use it like for like network services and things like that. You will have to know the systemctl for that. But again, that's kind of outside where you guys are at currently. But if you just want to add it to your notes, systemctl, system control, stop or start, and then service name. And starts and stops services. Okay, cool. Okay, what command will we use to start the same service? Doesn't get much easier than that. Did I type it right?
No, because it's on boot up.
Oh,
Boot up, so you have to enable it.
on boot up.
You have to
So that
systemctl
enable.
my service.
Yes, I did not see the boot up. I thought it was just starting it. What command would we use to bring a previously background process to the foreground? So foregrounding.
Is it like
FG. Boom. Okay, automation. Let's talk about Cron. Okay, so Cron, like we said before, it is a tool that is used to automate processes like a timer. And you'll notice it has this, it's kind of unique. You can see here 0, 5, ** 1. And that is the value as far as time. What minute, what hour, what day, month, week. And there's tools that you could put in when you want, and it'll spit those numbers out for you. But if you're doing it all the time, it becomes second nature. You can go here, like they mentioned, Cron tab generator or Cron Guru to generate the formatting for you. So we could see here, your cron job will be run at 426, 426 again. So this is running every 12 hours because it's at 0 and then 1200. Okay. So ensure you are connected and deployed instance and look at running cron tabs. Okay, so which one is this? Who are you? You are my local one. When the cron tab is deployed on instance, so we do cron tab and C. Did I spell it? I spelled it. Okay, so we could see it there. And then the other one that we had was -L, and that would list it as well. So when the cron tab on the deployed instance run, and it looks like it will go on when? Looks like reboot to me. Boop, 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 boop. Package management. This is something that you'll be doing, especially if you're on an Ubuntu machine or a popular distro. Updates come all the time, so you'll be able to see, or you'll always get security updates and application updates. It's really nice to the way that Ubuntu works because you can just type in the name of it. You could do an apt-get and then the name of the file, and then it'll allow you to download it from the repository. Okay, so if we're looking for a tool like, let's say, Nmap or Google Chrome or any of that, as long as you've added the repository to the sources list, you'll be able to pull that file down. Okay, so you'll be able to do an apt install, and it'll allow you to pull it down. Ubuntu started using a newer one. The snaps. It's okay. There's some I have some apps that are snaps, and others are still in the kind of apt repository. But we might be moving to snap in the very near future. Okay, so we'll talk a lot more about updates when we do our Ubuntu installs. Okay, system log files. So this is where we're going to spend a ton of our time as cybersecurity experts, because we want to know, if we're defending, we want to know who accessed what, and if we're attacking, the log files are going to tell us who logged in. We might get usernames, passwords, other information, depending on how things are configured. So log files are super important to know. And from our previous rooms that we did, where are the logs actually saved? Where are logs saved in the operating system? Remember, there was /etc/home/var var log. Yes. And what does var mean? Variable. Correct. Good job, guys. Var logs. That's where all your log files, most of your log files, are going to live. Look at the Apache 2 logs on the deployable Linux machine. Okay, that's this one here. So we'll cd into /var/logs. Log. We'll do an ls. Go into Apache 2, right? That's one of the ones we're looking at. And let's see. Okay, so we're looking at them here. What is the IP address of the user who visited the site? So let's look at our access log. Cat access.log. So it looks like it's 10.9.232 is the one that accessed it. 10.9.232.111. Woohoo! And what file did they access? Can anybody tell me? Yep. Well, we got the IP. We know that's 10.9. We see that here, right? Yep. catsanddogs.jpg. It's right there. This looks good. Woohoo! And we have finished Linux Fundamentals 3.